All right, everybody, we're now going to learn how to use the first and second derivatives to find the absolute max and min on certain intervals. Basically, here's the idea. We're going to look at, in the previous sections, we were looking at relative max and min, which meant like the maximum or minimum around that neighborhood of points, that small little area of points. Here, we're going to look at an entire graph or a part of a graph and say what is the absolute max and min for that piece of graph we're looking at. Now, it's basically exactly the same as what we did before, but there's one extra rule. So here's the idea. For absolute max and min, here's the idea. Once again, we take the first derivative and we see where that first derivative is equal to 0. By default, where that's equal to 0 is a likely candidate for a maximum or a minimum. However, there's one other thing that we need to keep in mind. Remember that the derivative is a limit. Call back to the limit as h goes to 0 of f of x plus h minus f of x over h. That's the derivative. The derivative is that limit. Now, if we're only looking at one section of graph, there's a little bit of a problem. The problem is this point right here and this point right here. It turns out at the end points of the section we're looking at, this limit will not exist because we don't have a left hand and a right side limit, and we don't have a left hand and a right side limit. So basically the derivative will check all of these infinite number of points for us, but it will not check this point and it will not check that point. So we need to test where is the derivative equal to 0, but then we also need to test the end points of our region. And by the way, you should also test any points that are undefined, except those are likely going to be asymptotes. All of these together are called critical points. And what's cool is, even though there's an infinite number of points from here to here, all you need to do is check these points and you're guaranteed, if your function is continuous and if the derivative exists, you're guaranteed to have the maximum or minimum be at one of those three places. So for example, in this first one, if we're just looking at this graph, the absolute minimum is right here, and it looks like that's the point 65, 32. That's our absolute maximum. We can check this point, but we see that it's neither the absolute maximum nor the absolute minimum. The absolute minimum occurs at this endpoint over here at the point 6, 5. So here's the absolute minimum at an endpoint, and here's the absolute maximum where our first derivative is equal to 0. So those would be the 3 points we would need to check to find the absolute max and min for just this section of graph. All right, that's all we got for this section. So in the next video, we'll look at an example for when we don't have a graph to help us.